Okay, let's get into it. Number 10. The light flashes behind their eyes. Picture it. You're 3 days from Earth, strapped into a cramped metal cone, and you finally close your eyes to sleep. And that's when the lights start. Little streaks, sharp white dots, thin lines drawn across the dark, one after another, as if someone were flicking a sparkler somewhere behind your face. Your eyes are shut. The cabin is black, and you are still somehow seeing. Neil Armstrong noticed it on Apollo 11. So did Buzz Aldrin. And when later crews reported the same thing, NASA realized this wasn't one tired man imagining fireworks. This was happening to everyone who left the protection of Earth. Here's what's actually going on. Out in deep space, away from our atmosphere and magnetic field, we're bathed in cosmic rays. These are atomic nuclei, stripped bare and flung across the galaxy at nearly the speed of light. And some of them pass straight through the spacecraft, straight through a human skull, and straight through an eyeball. When one clips the retina, the brain does the only thing it knows how to do. It says, "That's light," and you see a flash that was never really there. But here's the thing. Knowing what causes it doesn't mean we know how it works. On Apollo 17, the crew wore a device called the Apollo Light Flash Moving Emulsion Detector, basically a helmet that recorded particle hits while the astronaut called out every flash he saw. In one session, 17 flashes were reported, and 2 of them lined up with heavy cosmic ray nuclei crossing an eye. Good enough to convict the cosmic rays. Not good enough to explain the crime. Because there are at least 3 ways that particle might be making the flash. It could be Cherenkov radiation, a faint cone of real light the particle sheds as it tears through the fluid in your eye. It could be the particle physically jolting the retina into firing. It could be knocking the light-sensing molecules themselves into the wrong shape. 50 years later, we still can't say for certain which one it is. And every astronaut describes them a little differently. Streaks, blobs, comets, double flashes, as if the same galaxy is speaking to each nervous system in a slightly different dialect. So the next time someone tells you space is empty, remember this. Out there, with your eyes closed, the universe reaches through the walls, through the bone, and taps you on the retina. And for a moment, in total darkness, you see it. Number 9. The lost Apollo 11 tapes. Everyone has seen it. The ghostly gray figure hopping down a ladder. One small step. It's one of the most watched moments in human history. And what almost nobody realizes is that the version we all watched was the bad copy. The good one is gone. When Apollo 11 beamed its television signal back on July 20th, 1969, it came down as a slow scan format that ordinary TVs couldn't display. 3 tracking stations caught the raw feed. Goldstone in California, Honeysuckle Creek and Parkes, both in Australia. On their monitors, the picture was noticeably sharper, cleaner, clearer than anything the world saw. To broadcast it live, NASA had to point a regular camera at one of those monitors and convert it on the fly, and every step of that conversion smeared the image a little more. What 1 billion people saw was a photograph of a screen, but the pristine originals existed. Roughly 45 reels of 1-inch telemetry tape, holding the raw, undegraded moonwalk. And at some point, they simply stopped being where they were supposed to be. For years, no one could find them. So in the early 2000s, a team of retired NASA engineers went looking. The search was led by a video engineer named Richard Nafzger, and what he eventually confirmed is almost worse than a conspiracy. It's a supply cabinet. Here's the thing. In the early 1980s, NASA was running short on magnetic tape. Blank reels were expensive and hard to get, and there, sitting in storage, were thousands of old telemetry tapes that no one was actively using. So, to save money, they were degaussed, wiped clean with a magnetic field, and run through the machines again to record new data. Nobody flagged the Apollo 11 reels as sacred. To the system, they were just inventory. The sharpest recording of the first time our species touched another world was almost certainly erased to hold routine satellite data. The team never found the originals. What they did recover were the best surviving broadcast copies, and, weirdly, some Super 8 home movie film that an engineer in Australia had shot, pointing a camera at his station monitor. Amateur footage of the good version, because the good version itself was gone. And that's the part that lingers. We kept the rocks, we kept the flags, and the checklists. But the clearest images of the moment itself were recorded over to save a few dollars a reel. History didn't lose them in a fire. It filed them under blank. Number 8. The moon dust that poisoned the crew. Harrison Schmitt was the last man to step onto the moon, and by the end of Apollo 17, the moon was making him sick. Back inside the lander, helmet off, he started sniffling. Congestion, a raw throat, watering eyes. He described it himself as a kind of lunar hay fever. He was, in the most literal sense, allergic to the moon, and he wasn't alone. Every crew that walked out there came back coated. The dust got into everything. It ground into the seals of their suits until they wouldn't close properly. It scratched their visors. It clung to fabric and metal and skin like it was charged, because it was. And when they took their helmets off, all 12 moonwalkers noticed the same strange thing. It smelled like spent gunpowder. So why is moon dust so nasty? Part of it is the shape. On Earth, wind and water tumble grit into smooth little grains over thousands of years. On the moon, there's no wind and no water. The only thing shaping the dust is a constant, ultra-slow rain of micrometeorites smashing rock into powder. That leaves the grains jagged, sharp, like microscopic broken glass that has never once been worn down. But here's the thing. It might be more than just sharp. When that fresh dust meets the moisture in a human lung, some studies suggest it can generate hydroxyl radicals, highly reactive molecules that pick apart the cells around them. Add in the fine iron scattered through the dust, and you have a material that is abrasive, clingy, and possibly chemically corrosive to living tissue. We built machines to survive the moon. We're less sure the human lung can. And now, the twist that makes it genuinely unsolved. That reactivity may fade once the dust sits in Earth's air. The samples we have studied for decades have been quietly breathing our atmosphere, calming down, losing their edge. Which means the dust we test in labs might be a gentler, diffused version of the stuff that actually irritated the astronauts. We may never have properly measured the angry version. For Apollo, it didn't matter much. The crews were up there for days, and the symptoms faded. But the next people who go are meant to stay for weeks, then months, sealed in habitats with dust they can't fully keep out. Schmidt's stuffy nose was a warning shot from a world that has no interest in keeping us comfortable, and we still don't fully understand what it was trying to tell us. Number 7. The heartbeats that went wrong on the moon. James Irwin's heart nearly gave out on the moon, and he was one of the last people in the solar system to find out. Apollo 15, summer of 1971. Irwin and Dave Scott ran the most ambitious surface mission yet. 3 long moonwalks, a rover, heavy digging, heavy lifting, in stiff pressurized suits under a punishing schedule. By the end, both men had swollen, aching fingertips, their nails pulling away from strain. And they had been awake, working, for something like 23 hours straight. Down in Houston, the flight surgeons were watching their vital signs stream back across 250,000 miles. And on Irwin's readout, something was wrong. His heart had slipped into bigamy, A rhythm where a normal beat is shadowed by an early, premature one, over and over, like a limp in the pulse. At one point, he ran a stretch of what the doctors called nodal bigeminy, more than 20 beats of it. This is the kind of rhythm that, on Earth, gets you rushed into a cardiac unit. But here's the thing. They were on the moon. There was no cardiac unit. There was nowhere to go, and nothing to do but finish the mission and fly home. So the doctors watched. And they made a quiet, brutal call. They largely kept it from the crew. Telling a man his heart is misfiring while he's about to pilot a spacecraft off the lunar surface doesn't help him. So Irwin flew home not fully knowing how close the line had been. Why did it happen? The leading idea is electrolytes. That much exertion, that much sweat, especially after training in brutal summer heat, can strip the body of potassium and magnesium, the very minerals that keep the heart's electrical rhythm steady. Drain them low enough, and the heart starts to stutter. Apollo 15 became the first spaceflight in history, clearly marked by serious arrhythmias. And then the part that still isn't settled. 21 months later, back on Earth, James Irwin had a full heart attack. He was in his early 40s. Some researchers think the strain of that mission, the electrolyte crash, the stress on his blood vessels, may have quietly set the stage for it. Others say you can't pin a heart attack on a trip to the moon. We genuinely do not know. What we do know is this. For a few beats on another world, a human heart lost its rhythm. And the only witnesses were a room full of doctors, listening helplessly from a world away. Number 6. The Mascons. There are places on the moon where gravity gets stronger for no reason you can see. No mountain. No visible mass. Just a patch of the moon that pulls a little too hard, tugging at anything that flies over it. And in the run-up to the landings, these invisible knots very nearly became a serious problem. They're called Mascons, short for mass concentrations, and we found them the hard way. In 1968, engineers tracking the lunar orbiter probes, the little spacecraft mapping the surface before Apollo, noticed the orbits kept drifting. The probes would speed up and dip when they passed over certain regions, as if something down there were reaching up and grabbing them. 2 JPL scientists, Paul Muller and William Sjogren, put a name to it. Something massive was buried under the surface, and the timing could not have been worse. Right as NASA was fine-tuning the trajectories that would carry human beings down to the moon, they discovered the moon's gravity field was lumpy, uneven, and capable of nudging a spacecraft off its path. Get that math wrong. And a lander aiming for a flat spot could drift somewhere far less forgiving. So where do these hidden lumps come from? Here's the thing. They sit almost exactly under the great dark circles on the moon's face, the Maria, the ancient impact basins. And it took decades and a dedicated mission to work out why. In 2012, NASA flew Grail, twin spacecraft that chased each other around the moon, measuring the gap between them to fractions of a hair, mapping gravity in exquisite detail. What they found is beautiful. Billions of years ago, giant asteroids slammed into the moon. The impacts melted rock, splashed material outward, and left behind a bullseye of dense, heavy material at the center of each basin, ringed by lighter zones. That dense core is the Mascon. It's not a buried object. It's a fossil. A frozen scar from the most violent day that patch of the moon ever had. And that's the quiet twist. The very anomalies that threatened to throw the missions off course turned out to be the moon's memory of the impacts that shaped it. The danger and the history were the same thing. To land safely, we first had to understand how the moon had been wounded. We navigate around them now without a second thought. But every Mascon is a monument, sitting under the surface, marking the spot where something enormous once fell out of the sky and never fully left. Number 5. The moon's warm, radioactive interior. The moon is supposed to be dead. Small worlds cool fast. They lose their heat to space and go cold and quiet, all the way to the core. That's the textbook. So when Apollo drove thermometers into the lunar surface, the readings should have been boring. They weren't. On Apollo 15 and again on Apollo 17, the crews deployed the heat flow experiment. The idea was simple. Drill probes into the ground, let them settle, and measure how much heat is leaking out of the moon from below. That number tells you how warm the interior still is, and how much radioactive material is buried down there, slowly cooking away. And the number came back high. Higher than a small, long-dead world had any business showing. The moon seemed to be leaking more internal heat than the models expected, which pointed to an interior surprisingly rich in radioactive elements, still warm, still simmering, billions of years after it should have gone stone cold. But here's the thing, and this is why it's still an open case. There were only 2 probes, 2 spots on an entire world, and it turns out both of them landed in just about the worst possible place to take a fair measurement. Both sites sit inside a region geologists call the Procellarum Creep Terrain, a large, unusual province of the moon that happens to be soaked in thorium, potassium, and other radioactive elements. In other words, we drilled our 2 thermometers into the one glowing corner of the moon and then tried to describe the whole thing. So, which is it? Is the moon genuinely warmer inside than we thought? Or did Apollo just get unlucky and sample the hottest neighborhood? Decades of reanalysis still argue about it. Later work, informed by gravity data from the Grail mission, suggests the global heat flow is lower than those 2 readings implied. And, almost comically, one study found that the astronauts themselves warmed the ground just by disturbing it, digging and driving and darkening the reflective surface, nudging the very numbers they were trying to measure. 2 data points, both from the wrong spot, both possibly contaminated by the people taking them. That's what we have for the thermal state of an entire world. And so the moon keeps it secret. We know it's warmer down there than a dead rock should be. We just can't say, even now, how warm the real moon actually runs. We put our hand on it once, in 2 places, for a moment, and it was warmer than we expected. Number 4. Big Bertha, the Earth rock on the moon. In 1971, the crew of Apollo 14 lugged a 9-kilogram lump of rock back from near Cone Crater. It was so much bigger than everything else they collected that they nicknamed it Big Bertha. For decades it sat in a lab, a big gray lunar breccia, unremarkable. And then someone looked closer and found a piece of home. Tucked inside Big Bertha is a small fragment, about 2 centimeters across, that does not look like the moon. It's brighter. It's made of quartz, feldspar, and zircon, a combination that on the moon is rare and strange, but on Earth is completely ordinary. It looks for all the world like a chip of granite. And granite is an Earth specialty. So in 2019, a team led by researchers at the Lunar and Planetary Institute made an extraordinary claim. That little fragment probably didn't form on the moon at all. It formed on Earth, roughly 4 billion years ago, in Earth's crust, under Earth's conditions. And then something threw it 250,000 miles to end up in a rock an astronaut would one day carry home. How? Here's the thing. 4 billion years ago, the young Earth was being hammered by asteroids far larger than anything today. A big enough impact doesn't just make a crater. It blasts debris clean off the planet, out through the thin early atmosphere, and into space. Some of that debris would have rained onto the moon, which back then orbited much closer than it does now. One of those flung shards, the theory goes, is sitting inside Big Bertha. And now, the part that gives you vertigo. If it's true, that fragment may be the oldest known piece of planet Earth. Not found on Earth. Found on the moon. Because on Earth, rock that old is almost impossible to find. Our planet is restless. Plate tectonics constantly drags the old crust down and melts it, erasing the record. 4 billion years of geology has scrubbed away nearly all the evidence of our own beginnings. But the moon is dead and still. Nothing there recycles. So a piece of the infant Earth, launched into exile long ago, could sit perfectly preserved on the lunar surface, waiting. Now, not everyone is convinced. Some argue the fragment could still be lunar, formed in some unusual local pocket. The debate isn't closed. But sit with the possibility for a second. To hold a pristine piece of the world we were born on, we may have had to leave it and go get it from the sky. Number 3, the water that shouldn't be in the samples. For almost 40 years, the science was settled. The moon was bone dry. Not low on water, not short on water. Utterly, completely without it, down to the last molecule. And it made perfect sense, because of how we thought the moon was born. The story goes like this. Early in the solar system's life, a Mars-sized world slammed into the young Earth. The collision was so violent, it vaporized rock and flung a glowing disk of debris into orbit, which slowly gathered into the moon. And in an event that hot, that catastrophic, any water should have boiled off and escaped into space instantly. A moon forged in that kind of fire had no business holding on to anything as delicate as water. So for decades, when scientists found traces of water in Apollo samples, they assumed it was contamination, Earth water, sneaking in during handling, not real. Then, in 2008, a scientist named Alberto Saal and his colleagues decided to look properly. And here's the thing. The evidence had been sitting in a drawer the entire time. Among the Apollo samples were tiny beads of volcanic glass, orange and green, frozen droplets from ancient lunar fire fountains, blasted up when the moon still had active volcanism billions of years ago. Saul's team used instruments far more sensitive than anything the original researchers had, and they measured the water content of these beads from the inside out. The water wasn't on the surface, where contamination would sit. It was locked in the core of the beads. It had come up from deep inside the moon and been trapped in the glass as it froze. The moon, it turned out, was never dry. Its interior held water all along, comparable in some ways to the source regions of Earth's own ocean floor volcanoes. The beads had lost most of it, over 90%, boiling off as they erupted. But what remained was real, and it was homegrown. And that quietly broke the story. Because if the moon formed in a giant water vaporizing impact, how did it end up with water baked into its very core? Either the impact wasn't as thoroughly hellish as we thought, or water was somehow delivered and mixed back in, or our whole picture of the moon's birth needs adjusting. The samples never changed. They sat in curation for 4 decades, holding the answer, waiting for us to become clever enough to ask the question. Sometimes the discovery isn't out in the dark. Sometimes it's already home, in a drawer, patient, keeping a secret we weren't ready to hear. Number 2. The object that followed, Apollo 11. On the way to the moon, the most famous crew in history saw something they couldn't identify, following them, and for years, they barely said a word about it. It was the outbound coast, the long, quiet stretch between Earth and the moon. Armstrong, Aldrin, and Collins looked out and noticed an object keeping pace alongside them. It seemed to be there, glinting, holding station. When they looked through the optics, it seemed to change shape, sometimes an L, sometimes a series of open cylinders, depending on how the light caught it. It was close enough to see. Strange enough to make 3 of the most level-headed people alive stop and stare. Now they had an obvious first guess. The S-4B, the big spent third stage of their own rocket, was somewhere out there behind them. Maybe this was just their own booster, drifting along on a similar path. It's the calm, sensible explanation, so they wanted to confirm it. But here's the thing. They didn't want to ask directly, because they knew that if they radioed Houston on an open channel and said we have an unidentified object following us, that single sentence would rip around the planet in minutes. The word everyone would hear is UFO, and the crew of Apollo 11 were not about to hand the world that headline in the middle of the most scrutinized mission ever flown. So they asked it sideways. They quietly requested the position of the S-4B stage, and the answer came back that the stage was thousands of miles away, far too far to be the thing sitting right outside their window. Whatever was pacing them, it apparently wasn't their own rocket. So what was it? NASA's eventual explanation is calm and probably correct. During the flight, 4 panels had been jettisoned, the covers that had protected the lunar module. One of those panels, a thin sheet of reflective material, could easily have been drifting near the spacecraft, tumbling, catching sunlight, looking far more mysterious than a discarded panel has any right to look. Reflective junk, made strange by distance and darkness. Probably, that's the honest word. Probably a panel. And here's what keeps it interesting. The men themselves, especially Aldrin, have been careful to say it was not aliens, not a spacecraft, nothing paranormal. But they also never fully forgot how odd it looked. 3 trained observers, the sharpest eyes we ever sent out there, watched something follow them toward the moon. And the tidy explanation still leaves the smallest sliver of a shrug. Number 1. The moon is older than it should be. We built an entire story of our own origins around the age of the moon. When it formed, where the Earth came from, how the solar system settled into the worlds we know. And the Apollo rocks keep quietly telling us that story starts earlier than we thought. Every time we look closer, the moon gets older. Here's how you even date a world. Inside some of the Apollo samples are microscopic crystals called zircons. Zircons are a geologist's dream, because when they form, they trap uranium but refuse to accept lead. And uranium decays into lead at a rate we understand with beautiful precision. So you count the uranium still there, count the lead it has become, and the ratio tells you exactly how long that crystal has existed. A tiny, flawless clock running for billions of years. Now here's the thing that makes zircons so powerful for the moon. A zircon cannot form in molten rock. It needs the surface to have cooled and solidified first. And early on, the whole moon was covered in a global ocean of magma, glowing and liquid, no place for a crystal to survive. So the moment you find a zircon, you've found proof that by then, the magma ocean had already frozen over. The crystal's age isn't just old, it's a hard floor, a minimum. The moon has to be older than its oldest crystal. And in 2023, a team took an Apollo 17 sample and did something extraordinary. Using a technique called atom probe tomography, they mapped that zircon atom by atom, counted the lead one atom at a time, and pinned its age at about 4.46 billion years, which pushed the moon's formation back around 40 million years earlier than the leading estimate. Some analyses stretch it toward 4.51 billion years, brushing right up against the birth of the solar system itself. Sit with what that means. The moon isn't a thing that happened to the Earth long after the fact. It formed almost as soon as there was an Earth to hit. The giant impact that made it, that flung a molten disk of debris into the sky and slowly gathered it into the moon we see, happened at the very dawn of everything. And we still can't fully explain how. The exact blow, the precise timing, why the Earth and moon are chemically so alike, these remain open questions, argued over the same gray rocks a handful of people carried home 50 years ago. We went to the moon and brought back its birth certificate, and we still can't quite read the date. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.